Okay, so let's take a look at some quasi-experimental design options. First, the non-equivalent control group. The non-equivalent control group sounds complicated. It's not that bad. A non-equivalent control group is any situation when your control group is not necessarily a perfect control, or it's not a perfectly equal control to the other group. One example of a non-equivalent control group, or a specific type of non-equivalent control group, is going to be when your control groups are not truly randomly assigned. What am I talking about? So let's say that you're doing research on students and you've got an intervention to see if their test grades improve. You have two classes of students that you're working with, and so in step one of the study, you're going to say, well, class A is going to be in the intervention group and class B is going to be in the control group. So class A and B both get a pretest. Class A gets the intervention and class B does not get the intervention. Then both groups get the post-test. So this is a non-equivalent control group because you didn't randomly assign your participants to be in the intervention or non-intervention group. You already had students in a class, maybe it was the 8 a.m. class versus the 10 a.m. class. And while there may not be major differences there, you can't say that there aren't any differences between people who take classes at 8 a.m. versus 10 a.m. Maybe people who take 8 a.m. classes are more hardworking. They choose to wake up earlier, and then so therefore they're more susceptible to influence. Maybe the teacher is better at teaching at 10 a.m. because they've already taught the same information one time. Who knows? There's so many things that you can say about this quasi-experimental design. But of course, it would be pretty much impossible in many cases to apply an intervention totally randomly between a bunch of students like this. And so it's very convenient and useful to use a quasi-experimental design here. Not necessarily going to ruin your validity, but it's just something you need to be aware of. Another situation where you might want to use quasi-experimental design is in single subject research. A very common form of single subject research, or a very common type of research that employs single subject research, is going to be applied behavioral analysis. Also known as ABA, applied behavioral analysis is a type of research or a type of psychology that really focuses in on the relationship between behaviors and your environment. What does that even mean? So an ABA psychologist might think about whether a dog learns to be potty trained or not potty trained. And so if your dog is peeing inside and you scold them for peeing inside, an ABA person might say, well, there's something about the dog's environment that's making him pee inside. And so maybe the attention of being scolded is kind of a reward for the dog. And so they're going to keep peeing inside because they like the attention of being scolded. Maybe they don't understand that being scolded is bad. Maybe they don't care that being scolded is bad. They just like the attention. And so an ABA researcher might use a single subject, so the dog that's having trouble getting potty trained, and investigate them or apply some sort of intervention to them. Say, you are no longer going to scold them for peeing inside. Instead, you're going to try and reward them if they ever pee outside. It's going to be a quasi-experimental design, of course, because, well, there are so many factors involved in a single subject research that you cannot control. And part of what part of the multi-subject research design is that by having a bunch of different people participate in your study, you're kind of smoothing out any random chance effects of any one individual person. And so it helps get rid of the quasi nature that any research is going to have. The single subject analysis or single subject research applied in applied behavioral analysis is always going to be a bit of a quasi experiment, because you're going to work with the quirks that being using a single participant is going to bring you. Now, a very related aspect of research is the ABA design. Now, the ABA design stands for a research design where you have two conditions, condition A and condition B, and you apply them in that order. Usually condition B is going to be an intervention. So in condition A, there's no intervention. And so an ABA design is going to look something like this. Say on this graph, we're working with how much does the dog pee inside. And so Condition A, no intervention, they're peeing inside a lot. Condition B, you're applying some intervention, like rewarding them for peeing outside. The behavior of peeing inside goes down. And then you go back to condition A. You're not rewarding them for peeing outside anymore, and they start peeing inside again. What is the value of this ABA design? Well, it allows you to get a control condition using just the single subject. Of course, you have a control condition. You're watching how they do before the intervention, and then you apply the intervention. So why do we need this last section here? Well, the idea is to show that when you get rid of the intervention, the behavior comes back. So it really is that intervention that's causing the behavior to go away. By observing the behavior returning in that second A portion of the study, you're creating a better causality there. But you're never going to be in absolute control of everything in this sort of study because you're always going to have time as a factor. So it's going to be a quasi-experimental design, but this helps you get over the non-equivalent control problem, or the single subject control problem, or the time problem. There's lots of little different things. And I do recognize that this is kind of confusing because there's applied behavioral analysis, researching the behavior, and ABA, a certain type of design where you do the control, intervention, and then control again in a single participant. So I want to make sure you understand what those two different things are and that they are different things. Let's take a look at another type of design. So you have ABA design that we just talked about, where you apply the control, the intervention, and then the control again. But there's also ABAB design, so the control, the intervention, the control, and the intervention again. Of course, this is a little bit better than ABA design because it helps you solidify the connection between the intervention and the effect of the intervention. ABAB design is better because if you actually want to stop your dog from peeing inside, you're going to want to apply that intervention forever, and so you might just end with the intervention and have it keep going. Some other options you have for quasi-experimental design involve multi-site or multi-center designs. This is not necessarily limited to a quasi-experimental design, but it's definitely going to be valuable and for any sort of research, and especially for those quasi-experimental designs. A multi-site research is where you have researchers do their same research but in different places. So you're going to get participants potentially from different cultures or regions, or you're getting a little bit more variability. Multi-center design is where you're going to have different researchers in different parts of the world do the same research to see, in both cases, if the research comes out the same way, if the results come out the same way. Why is this useful? Well, of course, in quasi-experimental design, you're dealing with variables you can't fully control. And so since you can't control whether you can't control sex and you can't control age, you can control for those factors by doing the research over and over again, or by doing the research under different conditions to see if the research comes out the same way. If you remember last week's topics that we talked about, replication and extension and converging evidence, multi-site and multi-center designs are in effect forms of replication or converging evidence, since you get the same results over and over again with not necessarily the same conditions. We also talked about multiple baseline designs last week, just very briefly. As a reminder, a multiple baseline design is one where you have participants who are going to be observed for a period of time. Say again, we're looking at, okay, how often does a dog pee outside? And then you apply an intervention, say rewarding them or praising them for peeing outside. Now, your multiple baseline design is going to be for a situation where you want to give everyone the intervention, but you still want to see whether time was a major factor in how people were affected by the intervention. So the multiple baseline design has different participants getting the intervention after different amounts of observation, so you can see whether this amount of observation changed anything. You can see if people were naturally getting better or if it was the intervention that made them better. one way to deal with time as a problem for those quasi-experimental designs.